Hello, there is Impossible Creations, and in this video I will show you how you can set up your object to work with optimizers. If you did not see first video, please check it before watching this one. In this video I will tell you about shared settings and setting up obstacle detection component. There we have simple scene with campfire, there is again light object, but with particle systems inside. We will change visibility of light and intensity of particle systems regarding if they are behind some collision obstacle. Let's start by adding detection optimizer component. Let's disable gizmos of manager, we don't need them there. So, it's the same inspector window as in basic optimizer, but there is additional blue section. Here we define logics for detection obstacles. But first, for tutorial purposes, we will adjust some settings to again visualize everything what is happening. In this tutorial we have two particle systems, and let's say both of them will have the same multipliers of emission, etc. To change settings for both particle systems simultaneously, we can use shared settings. Each shared setting file contains parameters for different LOD levels and only for one type of component. So light component can have own settings file, particle system will have own settings file, etc. Inside the inspector window now we can assign settings file or create new one from our current LOD settings. Instead of clicking button new on each type of component, I will go to first LOD settings, where is prepared special button to save all unsaved settings. I will put them in new directory. Saving file generated automatic name, so it can be easier identified later. Now pop-up for light and again for particle system, but I will use the same file for both. Now you can see these files, they are here, and inside you can see different settings for our LODs. You can change them from here or through inspector window. And now when we change settings for one particle system, it's also changing in other, since it's the same load settings file. As I mentioned in previous video, using shared settings is more safe and universal to work with all Unity versions. Okay, now let's start working with components. Light object have additional flicker component, which is changing intensity of light during update, and it would conflict with changes of optimizer's component. We could put flicker component to optimizer, and instead of changing intensity of light component, we would change flicker intensity variable. But let's not do such complications for this tutorial. We will just tell optimizer to not change intensity of light. And as the same as in first tutorial video, we will change ranges to be very small, so work of optimizer component will be better visualized. Of course, in-game you would make these ranges more customized. Let's turn on transitioning and check that shared settings are working and see how particle systems are modified. Using optimizers on particles often can give very nice effects. One thing is changing their emission rate lower and changing particle size higher to make quality change at distance not noticeable. We can disable particle system when we're not looking at it. When it's very far away or you're not looking at particle system, it still takes CPU to compute simulation. And with optimizers, you can easily control what's going on when you not look at particle systems. Okay, it's working, so now let's focus on obstacle detection. In game scene, you can see this race going from camera. If all of this race would be blocked by obstacle, object will be hidden. If any of this rays will go to this small green sphere, object will be visible. You can define precision of checking visibility and add important points on your model to checking visibility. You can automatically add a lot of them, spread them over detection sphere how you want. But for this tutorial we will use only 4 rays. But instead of using automatic positions, we will adjust it a bit. For example, we don't need to cast ray from lower part of detection sphere. I will adjust these positions to be on the edges of sphere, but not forgetting about one ray in center. Also, don't forget about setting right coverage mask for your game to detect collisions correctly. I will change the detection sphere to be lower, again just to visualize everything for you. Alright, I think it's done. Let's add colliders to models on the scene. That will be mesh colliders. Now in scene view you can check how camera is casting these rays. So they are directional to camera position. Let's go behind the rock and I will show you what's going on here. And look at this green sphere. It's last ray not covered by obstacles. When I would move camera to the right a bit, object would be cooled. Let me add here sphere to see it more physically. I will position it to the ray. Now you can see this last ray position here. When I will lose it from sight, hidden LOD settings will be applied. But let's say we don't want to cool object or deactivate light when we not see this. We only want to change intensity of particle systems. So we open hidden LOD settings, make it not cool object, only changing emission of particles very low, and not disable light. Now when we lost this detection rays from the side, particles will have applied hidden settings. If you would have a lot of particle systems like this and with high emission, this optimization can do a lot. Raycast detection algorithm is cooperating with optimizer's component in a way that if object is not visible in camera view or is very far away, then raycasting algorithm is not computing itself, so it's working only when it's really needed. Alright, that's all for this tutorial. I hope it was helpful for you. Subscribe if you want more. Hit the bell for notifications about new videos. Thank you for watching and see you next time. Bye bye.